In this video we have another trigonometric integral to evaluate. In this case we have two trig functions taken to the third power, sine and cosine. So let's see how we can set this up. This should be the integral. I have sine cube and cosine cube here. And I want to point out that there is more than one way to set up or solve the problem. And your final answer might not look the same if you work it two different ways. But you can show that they're the same. And that's why a lot of instructors don't like to assign these types of problems to grade, because they have to follow each step. They can't just look at your answer, because your answer might be different than what they have if you worked it different. But let's start by setting this up this way. This will be sine cube of x, and then the cosine, I'm going to break it this way. They got a factor of cosine. So I'm going to say sine cube x cosine squared. So this is the same thing as what we started off with. Just broke down the cosine cube into cosine squared and cosine of the variable x. So I'm going to try to simplify this by writing it in terms of one function. It could be in terms of sine or in terms of cosine, and again your answer will be different depending on what approach you take. So here's what I'm going to do. So this will stay sine cube x, and again we've done this before in other videos. Cosine squared, we know that sine squared plus cosine squared of the same angle is always equal to 1. So solving that, again I'll have it sine squared of an angle, in this case we'll use x, plus cosine squared of the same angle equals to 1. So I'm going to replace cosine squared right here from this equation, this identity, your basic fundamental identity. Solve this for cosine squared. I'll get cosine squared. Bringing this over is 1 minus sine squared. So this will be 1 minus sine squared of x. And I'll have the cosine here. And then I'm going to multiply through by sine cube here. So this will equal to sine cube x, multiplying 2 by 1, multiplying the sine cube x by 1 there. And then multiplying the next term, sine squared, this will give me sine cube, or I should say sine to the 5th here, square root of cube, so this will be sine to the 5th, and then I'll have the cosine of x dx. Like I said, I could have broken it up the other way and put the sine over here instead of cosine, and have a cosine cube, and then things will come out different here. And now since the derivative of sine is cosine, this suggests I use the substitution method. So let's let u equal to sine of x, and then du will equal to root of sine is cosine of x, and then this will be dx. So then I'll follow up then with my next step will be I'll put it up here. And this will be the integral then. Then I'll make the substitution. So u is sine here, so this will become then u to the third minus sine to the fifth, but u is sine, so replace the sine there by u, and this to the fifth power. And then from this one right here, dx will equal to du, dividing by cosine there, both sides of that by cosine, du cosine of x. So right here, I replace this dx here by du over cosine. The cosines will cancel, and this will just give me du out here. So that's my next step. And then I got some simple integration with respect to u. So the antiderivative or the integral of u to the third would be add 1 to the exponent, that'll be a 4, and then divide. I get a 4 down here. And the next one the same thing, add 1 to the 5, that becomes a 6. Divide by that value, 6. Add my constant of integration. And that's pretty much the setup. Now it's just a matter of going back to the original variable. You know, u is equal to sine of x. So we just put here sine, u is sine. Of x, and that's to the fourth power. Put a 4 here for the exponent, and that's over 4. Minus, and then again u to the 6, but u is sine of x. And that's to the 6th power. So we're 6. Constant of integration, sine to the 4th over 4 minus sine to the 6th over 6 plus your constant of integration. And again, we could have gotten a different answer if we broke it up the other way. Instead of having the factoring out the cosine cube, we could factor out the sine cube, and this would come out in terms of cosine. But the answers would be identical. Identical in the sense it's the same expression. They would look different, but this is the solution for this one. Thanks for watching. We'll see you next time.